So welcome back, everyone who's already back. I'm happy to host the tool vendor session again here at the DSM conference. We are always having a slot where tool vendors can show us their tools, how to work easily and more convenient with these and to use the full potential of these technologies. Today we are going to have 5 presentations here from the tool vendors flow. So we're going to start with Paul Woskett, then we are going to have presentation for Boxar, Lattice, Site, and Project DSM. Just a little hint for you, we also have the DSM web page where you can find information on all software tools that you can use, commercial tools that you can use for working with DSMs. I'm putting the link in the chat so you can check on them as well. Most of them you can find there, Site not yet, but we will hear a presentation on it from Frank. So without any further ado, I would say let's start with the presentation on flow. Paul, are you ready?
I am. I'm getting a message on screen saying I can't start screen share while others are participating in sharing. That's better.
That's a pity.
Thanks, Jakob.
Now it should be possible.
I think it is. Are you seeing the slide that says introduction to flow?
Yes, perfect.
Excellent. Okay, thanks, Jakob. So I'm Paul Woskett. I'm a director at Debt Management. We're a consultancy and software business specializing in process modeling and management of large, complex engineering and product development projects, with offices in the UK where I am, and also in the US. We provide a range of services, and we use a variety of tools and techniques to support the engineering stage of those large projects. And those services which deliver the most value to our clients all rely on DSM as an underpinning technique for optimizing the process. And we've developed the flow tool. This is the latest incarnation of a product that was previously called Adept Design, and prior to that was called Plan Weaver. The flow is somewhat different, and I'll explain some of the differences in a moment or two. It's a tool which allows us to maintain a process-focused DSM as a result of the process data that we hold in our projects. Now, a couple of the things that make the engineering stage or the product development stage of projects so challenging to deliver on time and to budget are that the process is driven by the flow of information, which is very often intangible. So that's a huge challenge in its own right. And unlike linear product development or manufacturing processes, the engineering process or the product development process contains interdependence as well as dependency, and therefore iteration. And you can just see on screen there's an example of that highlighted there, where we have a small iterative process. And the presence of this iteration and the nature of the process being information driven makes DSM absolutely ideal for optimizing that process in a way that, for example, the critical path method isn't. So flow is, I'll introduce flow in more detail in a moment or two, but just as an overview, we use flow to implement, in effect, 4 stages when we deliver projects. We define the process, we use DSM to streamline and plan the process, and then as we deliver the project is delivered by engineers or product developers, whoever's involved, we are using the DSM and the plan to ensure that the project is delivered as predictably and as reliably as possible. So just a little bit about flow before I get into that detail. It's a cloud-based system. It's accessed through a web browser. It acts as a central repository for all of the process information, project process information within the project. And it's got some fairly sophisticated functionality, which unfortunately I'm not going to have a chance to talk about in detail today. I'll mention 1 or 2 elements of this at the very end, just as a reminder. I'm going to cover the basics of defining, streamlining, planning, and delivering projects, but there's things like change modeling and knowledge-based modeling, which are a fairly sophisticated piece of functionality that sit within the tool. So let's talk about those stages. Let's start with defining the project process. So we use Flow. This is a screenshot of Flow. We use Flow to break down the process in the form of a breakdown that you can see on the left-hand side of the screen there, a work breakdown structure, if you like. So structuring the process. And we define the activities within the process, those tasks that need to be undertaken by whether they be engineers or product developers or whoever they might be as part of the project team. We define the characteristics of those activities, who's doing them, how long they're taking. We can get into how much effort's involved and therefore how much they cost or forecast the cost. And then critically, we're defining the information that those activities require and the information that they produce and where that information comes from and goes to. So we're defining the flow of information through the process. And we work with the project team to put that in place, of course. Now, having defined the process in this kind of form, what we're often left with is a picture that tells us that it's highly complex. Well, we probably knew that at the outset. And this is where DSM really comes into its own. When you've got these very complex processes, it's a really, really effective tool, we find, for understanding what that process really looks like, for optimizing it, and for determining a sequence which we can then put into a plan. So we're using DSM, as you can tell, for process optimization rather than product modeling, although there is a relationship between the two, which I'll touch on in a moment or two. And within our DSM, we have the activities with the marks in the matrix representing the dependencies. The information flows between the activities, and below the diagonal line, those are information that's flowing freely through the team. Where we have marks above the diagonal, that represents interdependence and therefore iteration. So that's those little loops of iteration that we saw in that process model earlier on. And whilst those groups represent iteration, when we come to plan those, we don't plan iteration in its traditional sense. We want to plan collaboration and concurrent working between the parties involved, whether they be, engineers, developers, the client, whoever might be involved. And what we find is that those clusters of activities on the diagonal, those areas of interdependence and iteration, strongly correlate to elements of the project that require a close coordination, such as where we have physical interfaces between systems or components. So this is where you start to see that there is some sort of relationship between the process DSM and the product DSM. But this is definitely what we're looking at here is a process DSM. So I've talked a little bit about defining process and streamlining process. Then we plan the process. And we've put plan in, I've put plan in inverted commas here, because actually it's the DSM that's doing the planning. We generate views of the process like the pictures you've got on screen, either within Flow or we put that out into some third-party application, because that's what people are used to seeing. But it's the DSM that's doing the planning. It's the DSM that's doing the hard work. This is just a picture of the plan. So we've got a plan in place based on that optimization in the DSM and based on the definition that we've put in place. And that's a bit like having a map. It tells us what the route might be from where we are now to the end of our project, or wherever we want to get to within our project. But what we want to do with Flow and with the DSM is use it much more like a sat nav rather than a map. So we want to deliver the project, and as we do, we want to be told about blockages, barriers, constraints, things that are hindering us from delivering, so that we can do something about them, so that we can divert around them, or we can take action to remove them out of the way. And this is what we do as we deliver projects with Flow. So we start with, this is quite a complicated slide, there's a lot going on here, but we start with the, let me see if I can bring a pointer up. We start with the plan, what we sometimes call the integrated schedule. We generate out of that short-term look-ahead work plans for the different participants in our project. And then we have them every week or maybe every 2 weeks, depending on the needs of the project, report their progress, their issues, their blockages, their constraints, and any actions they can identify to overcome those constraints and those blockages. And that can then get talked about in a project team meeting. And we can agree how we're going to close those actions out, make sure we've got the right responsibilities, get people committed to closing them and get them closed. so that we stay on course as best we possibly can. And out of that, we get an updated schedule, and we re-optimize each week or each period using the DSM. And then we repeat the process and we generate into the next set of work plans. So we're going through this cycle every week or every 2 weeks, where we're based on the performance of the team, the progress and the issues that are preventing them from delivering, we are re-optimizing using the DSM. Now, this is what it looks like to a participant within our project team. They have their work plan and they report their progress, and they can see the status of their work, their tasks based on their progress, but also the progress of everybody else. And as we have them report on their progress, and we're mainly interested in time, but we might also be interested in effort and therefore cost. We have them report where they're not able to deliver activities as per the plan on the reasons why. And this might be that they're awaiting information from another party. They might be awaiting decisions out of their client. They might have resource shortages. There might be all sorts of things. And as a result of that, we have each week or each fortnight, each 2 week period, a list of the issues and problems that are preventing the team from delivering and the associated actions in a central location within Flow. And we can talk about that within a design team or a project team meeting, as I described, and get commitment from the team to close those actions. So that's the basic sort of process we go through as we deliver the project. I just mentioned a couple of these earlier on. There's some high value features of Flow, and chief among them, of course, is the fact that there's a DSM scheduling engine at the heart of the system. There's also the issue and action management, which is a significant feature. Things I haven't mentioned are change modeling, the ability to target specific driving paths to major milestones or major activities, the ability to plan resources and costs as well as time. We're primarily interested in time in a lot of our projects, but we might also be interested in cost based on resource. And also the ability to generate the definition at the front end based on a knowledge-based approach, which uses the scope of the project to determine the definition. Just to wrap up, I'll tell you a bit about the benefits, and they fall broadly into 2 categories. You won't be surprised to learn that those categories are time and money. And I won't go through this in detail, but what I will do is just highlight a couple of key words there. Predictability and certainty. This is what Flow is all about. This is what your sat-nav is about. It's about getting you where you need to get to as predictably as possible, so that at any point you're able to say with confidence what your arrival time is and what the project's going to look like at the point where you arrive there. And that's what Flow is all about, looking for those barriers, those constraints, and removing them, and using the DSM as we go to optimize the process based on what we know about those constraints and those issues. And just final slide on benefits. What you're looking at on screen there are a couple of recent Flow projects on the right-hand graphs, a couple of other projects which are using what would be considered very best practice in process management in the left. And if you've got predictability and certainty, your dark blue line is tracking your light blue line as closely as it possibly can. And what you can see on the left is that those 2 lines deviate away from one another. You fall away from the target plan as those problems arise, and they prevent the team from delivering. With Flow and with the DSM optimizing the process periodically, we're seeing much higher level of certainty and predictability. Okay, that's a whistle-stop tour of Flow. If you've got any questions or want to follow up, my email address is on screen, paul.waskett@adeptmanagement.com. Please do feel free to drop me a note. With that, I will hand back to Jakob.
Perfect. Thank you very much, Paul. Great presentation. Probably you can also put your email address in the chat.
Will do.
Or your LinkedIn profile or whatsoever.
Yeah, will do.
Does anyone have a question? Well, if not, then I would have a very short question for you. I think it gets really tricky when you have those feedback loops, and you will probably, especially in agile projects, you will have those feedback loops. So do you already have experience with using Flow for agile projects?
Yeah, we've done some work in the IT sector, IT implementation projects, and it adds to the challenge because of the speed they're moving and the independence of the different disciplines involved. But that is one of the big challenges where you have those loops is whether it's agile or not, is getting the different participants working on those activities concurrently when they're working at their own pace and working on their own streams of activity. But you need to be very, very quick at spotting those problems and particularly where they impact those loops when you're working in an agile environment.
Mm-hmm. Okay. Well, thank you very much. I think it would be nice to see you also in the networking afterwards, so
Okay.
people can ask you questions or talk to you about specific projects. Okay, so let's move on to our next presentation from Ian, who is going to present Boxar. Are you already there, Ian? I can see you.
I believe so. Can everyone hear me?
Yes, and we can see your slide. That's perfect. So please go ahead.
Good afternoon and good evening, guys. So I'm one of the founders of Boxar. I hail from the aerospace and defense industry from Rolls-Royce, and it was probably there that some of the original ideas for Boxar came about. Boxar is a capability which is all about creating digital twins of various interdependency challenges. So for sure, product development process is where we began, but I think we recognized that there are things that we learned from there that we can apply in other domains, and indeed Boeing were kind enough to pull us into completely new domains that we hadn't thought of. So it's amazing how you can go from one domain to another domain and read across and learn from those folk. So very pleased to be involved in all sorts of different sectors these days, which makes life really interesting, really academically interesting as well as technically. And we're delving into more and more. So I'd like to introduce Boxar as a capability which is able to take a situation and allow you to represent it. So it gives you the ability to configure solutions and build digital twins by both exploiting existing data. So we're very good at importing data from various different information systems, often executive systems, but sometimes ad hoc. Also, and I think this is critical, and maybe this will be the back end of my presentation, eliciting the human expertise, and that's rather like herding cats, and I'm sure some of the tool vendors and some of the academics here will attest that, as well as professionals. It's very hard to extract from people their understanding of the dependency situation. But what we aim to do is to provide a model in the end that can be exploited both by end users who are not tool jockeys, but also people who are doing deep analysis. So the paradigm and the basis for Boxar's name is boxes and arrows, but we group those in various hierarchies, which I'll demonstrate with a very brief interlude into the tool. But I think what might be of interest is the ability to define what those things are that we're connecting. So it's not necessarily just activities, it could be something more abstract like a requirement, for example. And we can take those, define the relationships, which may be classic predecessor, but they could be other relationships, and then group them in different ways, different lenses, overlay with any data, and then do functional analysis. So actually do what you might do in Excel, go and calculate things up and downstream of the boxes and arrows and groups that we have. So that gives us a very flexible toolkit that we can apply to different use cases. And just to give you a feeling, whilst we may have started very much in the complex planning of products like gas turbines, where I came from, very much taking the technical thread through that planning and kind of using it to inform, look at the information flows and pull out optimal schedules, as we've just seen in the previous presentation. We can also bring in other things like the production systems themselves, the supply chains, and so on and so forth. So there's many different use cases once you start looking at dependency structures of different types. So I wish to just bring out the tool briefly, just to give you a feel. So we have the boxes, we have the arrows. We're very familiar with network views. We're very familiar with Gantt and DSM in this community. Boxar brings all of these views together in a seamless way. it also brings together the concept of multiple hierarchies. So oftentimes we're thinking in terms of work breakdown structures or product breakdown structures, but we might equally think through, well, who's responsible for that and where are they in the world? So Boxar's looking at all of these different ways of looking at the dependency structure and coordinating them through this tool and allowing you to navigate, filter, look upstream, downstream, etc. So I think we've just seen from Flow that you want to be able to take this dependency structure, the knowledge which you've accumulated, the logic here, the feedback loops, etc., and you want to be able to turn it into something actionable. And so, of course, we can look at various techniques, which I think many of us are steeped with from DSM. One of the things that Boxar does maybe a little bit differently is it's able to take this dependency structure, the durations, the resources, the resource constraints, and perform an optimization, which is actually a Pareto-based optimization. So we have discrete event simulation, we have a genetic algorithm, and it's able to give you a whole surface of solutions, some which will iterate some of these cycles more than others. And Tool is pretty good at identifying things which are cheap and easy to iterate, don't take very long, as opposed to things which are very expensive and have got very large cycle times. So with that, a few examples, industry examples. Frank Waldman and I worked on a common event a number of years ago at Carderock with the US Navy, so ship design process, showing the ability to drill into the information. Each arrow is an information flow. We aggregate the arrows in order to be able to show the flows and summarize them. This is an example from Rolls-Royce looking at the interdependencies of various whole engine systems, classic DSM with strengths in here, strong, medium, weak. And you tend to ask yourself, well, what does that give me? And I think one of the lessons learned is DSM is one of many really useful views of interdependency. It's a really condensed way of communicating dependency, and we should celebrate it. But it doesn't necessarily give you something immediately actionable. Oftentimes, everything's connected to everything. So that's an interesting lesson. Some other examples: nuclear power plant. This is a recent example, really working across multiple organizations, both the client operator, the main provider of the nuclear power plant, the supply chain involved, looking across discipline, across phase, across the work breakdown structure, really complicated mess. And I think that leads to one of the main challenges for this community is how do we elicit this in a really good way. Some other examples: Airbus's supply chain. It's just another dependency structure. We find cyclic dependencies amongst suppliers who provide material back to the main organization, which flows back into the supplier. So there's interdependency everywhere, and that's what we look at. So I wanted to leave you guys with some things which I guess many of you already know, but it's really remarkable how difficult it is to elicit things like the activity dependency. Any of the other domains I've mentioned, it's the same story. Especially when you've got really complex programs, multidiscipline, multi-party, multinational, multi-phase, multi-objective, etc. But that's not a reason to do less. You need to do more. You need to be able to rehearse and tease out where people don't understand or don't know what they're going to do in order to achieve the outcome desired. And I'll leave some bulleted points. It's not a complete list, but really, in my experience, you need to have excellent sponsorship at the customer level, at the senior executive level, and you need to get broad buy-in, not just by the top level organization, but by their supply chain in order to be successful. You need to get the granularity and the methodology right to elicit this information. You really need to put the right things into the models, because if not, you end up with a hell of a lot of noise, which you can't really manage, and you lose the goodwill of the participants. So I think there is a role for the tool vendors here and for the community to establish better ways of federating the modeling, providing both methodology and workflow, enforcing discipline, but also giving the flexibility to the end users who are the experts in the end. And we need to give them a reason to participate so that we can capture these dependency networks. So ways to visualize, navigate, different views. And those views include the DSM, but not just the DSM. And we really need to be very good at providing ways of navigating, filtering, summarizing the detail, and simply just avoiding the folks getting lost in this melee that we all come across. So I think that's right for innovation. Boxar is working hard, tool vendors are working hard, this community, and there's many other communities. I think we can learn from each other. Let me leave you with that.
Perfect. Thank you very much, Ian. I think it's also nice that you gave us some directions where we can work further on DSM technology. Again, does anyone have questions to Ian? We will. Frank Waldman, a long friend of our conference. You have two presentations, one on LaTeX, one on site, so we are very excited. You can choose whether you want to have both in line or with a break in between.
Yeah, they're quite different, so I'll have a little break to take questions as you've done before. And I can share my screen?
Yeah, I think so.
All right, so let's start this one. Hope that works. All right, everyone see my screen?
Yes.
Okay. Oh, actually, that's not the one I wanted to share. That's the actual website. So let me grab the desktop here. Yeah, there we go. And then should pick up. Here we go.
Now we can see the presentation, yes.
Yeah, and of course I start with the website. So LaTeX, you may not know about very much unless you're doing software engineering. So that's been our history. LaTeX has been around since 2003. We have 1,200 customers in 30 countries, lots of partners, lots of integrations. So we're very active. A very active company promoting DSM, and you can see we're promoting the DSM conference as well. So historically, people have used us for analyzing their architecture of software in particular. And so over the years, we've supported lots of different languages in software, frameworks, databases, all kinds of things where the system has a lot of interdependencies and people struggle with enforcing their architecture. And so we have a lot of features to help people reverse engineer what the architecture is from a legacy system. And then a lot of features have been developed to help people remediate the architecture, to refactor it and get a lot of value from. So these two have been our historical ones. Today, I'll just expand your knowledge a little bit. In the last 2 years, we've been focusing on how to use DSM to improve testing and building of software. So a lot of great opportunities there, a lot of pain there. And if a company has software and they haven't done unit testing, where do you start? Well, you want to start on the most important parts of the architecture, and that's where the DSM can be very effective. So we have a solution we call Smart Test, and it helps people achieve higher rates of testing. And in particular, it sets up well for continuous integration DevOps, which is the rage now. There's billions of dollars that are going into automating the production of software. Every company nowadays is a software company, pretty much. The car has more software in it probably than anything, or will soon, because it'll be autonomous. And so everybody wants to have their integrations done with their tool chain. And LaTeX sits in the middle of the tool chain. So it's very nice for us because we inform the build and we inform the testing, and we bring all the data into a heat map that helps people understand where in the architecture are the issues so that they can focus on them. And of course, that leads directly to compliance. So functional safety compliance for automotive, avionics, and medical are the primary customers for us now. And we are certified by the TÜV for compliance for the architecture pieces of the software that is in all of those embedded systems. So we have a lot of consulting work we do around achieving compliance faster. It's a big part of the business. And then finally, just in the last year, we've seen a tremendous interest in systems engineering. And you know, we've more or less focused on software, but we appreciate that it's a system of systems, and so we've dedicated quite a bit of energy to it in the past year. We start with UML for software, and then we've graduated now to SysML, which models the whole system, including requirements and everything that you should need to define the system. We've done some nice integrations with 3 tools in particular: Magic Draw and Cameo from Dassault, Sparks Enterprise Architect, and IBM Rhapsody. And so it's possible now to extract all of the model elements in SysML. There's maybe 40 different kinds of model elements, and there's 20 or so different kinds of relationships between those model elements, and they all are captured in a DSM. And you can see the flow of the model quite well. You can traverse a system with 20,000 elements, for example. And so that has led to the complexity view of the entire system. And so we've encouraged our customers, especially those in systems engineering, to look at a multi-domain DSM approach where they're capturing everything. And this is particularly beneficial for change impact analysis. So, you know, somebody goes out with COVID, for example. Well, you know, what's affected, you know, in all parts of the system. The transitive closure of impact can have many, many levels, and not just in the software, but throughout the system. So that has led more recently to us focusing on process architectures and complexity around that domain. And so we have made an integration with Microsoft Project and Oracle P6 so that we can access the data and put it into a multi-domain DSM for the same kind of analysis that you would conduct with other tools. And we have found there's some challenges, of course. People have trouble with what is a dependency and which way is the dependency represented. We've had trouble with representing multi-domains where people are used to seeing dependencies across a row versus seeing dependencies down a column in the DSM. And so we have these hybrids. We have different algorithms for different domains, as you can imagine, sequencing in some domains and clustering in others. And yet we want to see all of that information in a single DSM. And so we've had to expand the capabilities of LaTeX in order to do it. I mentioned integrations in getting data. And so we've added BPMN is one. We're doing OSLC, which is another one. We've already, of course, done all of the standards for SysML and UML, and for extracting data from, all kinds of other software engineering and analysis tools. So integration is a big part of what we've done with LaTeX. And at this conference, we're pleased to say that there'll be a number of presentations by our people who have used LaTeX, and we hope that you'll learn more when you see LaTeX in use by these customers. All right, so that's it on the LaTeX part. Any questions?
Thank you very much, Frank. To all of you, make sure to join those presentations. I think it will be nice to see LaTeX in work. Yeah, do you have questions? Questions from the audience? Not so far. Then maybe we can proceed with your presentation on site already. And if there are any questions on LaTeX, also write them in the chat. I will queue them up.
Yeah, and if anyone has any questions, they could also just reach out to me, frank.waldman@latex.com.
Yeah, perfect. Also, maybe you can put your email address in the chat.
Yeah, I'll do that.
So we can reach out to you.
Sure. All right. So switching over to site. First thing, I want to mention, it's actually another product that is from LaTeX. So we have LaTeX the product, and we also have Site the product. And we intended Site to be a really low cost tool for iteration management in projects. It's now live in beta, so it's a web-based application that anybody that has an account can then create a project and start using it. And there will be a presentation on Thursday by Leonardo Manzioni, who's been our alpha victim in testing this out. So I wanted to, just give a little background on where we see a site being used and how it's being used. So the idea is to enable people to create a diagram of a process with all of the information that they normally would put into it: tasks, iterations, roles and phases and so forth. And then and they can use a variety of tools. BPM is very common these days. There's lots of different tools that can do that. And then we import it into Site. And typically they when they're diagramming, they don't put durations in. So, we enable people to add the durations, and then we can create a DSM with different partitioning algorithms for as early as possible, as late as possible, and so forth. And then once you have that, you export the project to Microsoft project or P6, so that the planned iterations are summary tasks that are now decision points in the project, and then you do your normal Microsoft project planning with all the great tools that Microsoft offers for executing a project. And then once you have the project running, you can do your normal updating in project. But then when you hit unplanned iterations, you would then go back to Site, mark those iterations, repartition in the DSM, and then essentially what is exported from Site is an iteration summary group of tasks that need to be repeated, that then get inserted into your project plan, because we all know that these project planning tools don't handle iterations. They're all serial. So that's the overall approach. So the idea is during the architecting of the process, you get the benefit of DSM, and it's a bridge to Microsoft Project, where you can automatically create a plan there. So what does it look like? This is a diagram of a typical, in this case, a construction project that has a number of phases, and all of the roles that are involved in the project have their swim lanes, and you just sort of lay out the flow of how things are to be executed. Could be a template, could be just a from scratch new process, and each of those iteration points are decisions that reflect whether or not you're going to have to iterate. And so we call those planned iterations, and they're given milestones in project so that you when you reach that point, you make a decision. When we bring in a project through BPMN is the format, we can then create the work breakdown structure. In this case, it's fairly simple. It's just according to phases. In some plans, of course, there's lots of summary tasks, which are sub-processes that then get represented in the work breakdown. And so within site, you can define, you can change the work breakdown structure in site. You can add baselines, different element types, differentiate different relationship types, and so forth. So it's intended to enable you to add information as needed into your plan. And then within site, you do your sequencing depending on which algorithm you're interested in. Here you can see in this particular sequence, we have 4 iteration groups. These are all planned. And when you hit a particular decision task, which is a milestone, you decide whether or not you need to reiterate. If not, then you just tear those dependencies and away you go. There is a simple Gantt chart in Sight, although it's not really intended to be for the execution of the project. You would do that in Microsoft Project, but it's helpful when analyzing what you're intending to do with you've now got your duration information, and so you can know the estimated project finish date, durations of different subtasks, and so forth. And you can see the iterations in the Gantt, which is something that you don't see in Microsoft Project. So it gives you the ability to get that overview of it. Just to show a fairly simple technique for tearing dependencies or untearing them as appropriate. You just select it and then tear it and give it an explanation of why you're not having to do that iteration. So you can capture decisions that have been made in the execution of the project as it goes. This is what it looks like in Microsoft Project. There's an import and export add-ins that we've created so that you can bring in data. So if you have a Microsoft Project plan, you can just import it into Sight. But more importantly, you can export to Sight from Sight into Lattice. And this iteration group is what gets inserted into the schedule, and what's in the iteration group is determined by the actual cycle group and the path through. So it then inserts it into the schedule and creates a predecessor to the following tasks so that it can reschedule everything. And you now have a technique for unplanned iterations, especially. All right, so so that's Sight. We hope to have it through beta and launch sometime in early Q1. And of course, we're interested in anyone who'd like to give it a try. We would welcome more beta testers.
All right, thank you very much again. Again, quite impressive tool. Let me know when it's published. Can put it on our webpage as well.